This is Chapter 5 in Microeconomics, Elasticity and its Application. Okay, well, we're going to take a look at supply and demand in more detail with going beyond just equilibrium and looking at equilibrium when there's a double shift. We're just going to look at how buyers and sellers will respond to changes in market conditions in response to price, in response to income, related goods. So we've done this already. We're just going to take it to another level, look a little bit deeper. Okay, here's the definition of the price elasticity of demand. Sorry about that. Let me go back over here. Elasticity allows us to analyze supply and demand with greater precision. We're going to be looking at buyers and sellers and how they respond to changes in market conditions. And here's the definition again. Basically, we're looking at how responsive buyers are to changes in price. And we can measure it in terms of a percentage change. So we can actually collect data. So if you're the manager of Old Navy, for example, and you're thinking of maybe charging a little bit more for those t-shirts, well, before you actually end up with a shortage or surplus, maybe you can take a look at some actual data of what has happened before when we've raised. So you can take a look at the percentage change in price when we've tried to raise prices before and what happened to sales, and actually calculate what's going on and measure consumers or buyers' responsiveness to changes in price. All right, and I asked you to add in that percentage change formula to the top of your formula sheet. I forgot to add that in for you all. So right above total revenue, make sure you've got that formula. And I'll just show you an example of what we're doing here. You may have had to calculate percentage change before, calculating inflation, or maybe in chemistry when you were titrating a new chemical into a solution that you had. So let's say that you're used to going out to dinner at your favorite restaurant, and you're used to paying $10 for your meal. So we'll call this the old price, and then we'll call this the new price. All of a sudden, you go away for the summer, and you come back, and the same meal now costs $20. And I know these are really easy numbers, but in order to figure out the percentage change, this is new minus old, so that's 20 minus 10 divided by the old. And what's that going to equal? 10 over 10 is 1 times 100, so that's 100% market. Right? That's how you use this percentage change formula. And that's an example for when prices increased. Let's pretend that you've been at Dillard's and you see the suit that you have, really had your eye on, and it's $100. You're thinking, I don't know if I've got $100 now, but come back in a couple weeks and it is on sale. So let's figure out the percentage change. The new number is going to be 50 minus 100 divided by the old number is 100. So what is that? 50 over 100 is going to be a half. Right, 1/2 times 100, or 50%. So you might see all around Dillard's 50% off sale signs advertising this price change. So that's what we're doing. That's how you use that formula to figure out the percentage change. Okay, so again, elasticity, it's a fancy word, but it just means responsiveness to price. Are you going to keep buying that product or not? Do you care about if it's more expensive or cheaper? And this is just a way to measure it. Okay, determinants is just a fancy word for things that affect or will change our elasticity of a product. Okay, the first one is the availability of close substitutes. If we're talking about bottled water, for example, I've got Niagara up here that you can get from H-E-B. What are some other, I see several brands. What are some other brands of water, bottled water you can think of?
Deja Blue.
Okay, Deja Blue, Aquafina, Smart Water, Fuji Water. Okay, so we've got, what does this mean? If Niagara decides to sell $5 per bottle of water, I can easily respond to that, right? And say that's way too expensive. I can easily buy Hill Country Fair or Dasani or switch to something else, right? I can respond to that increase in price, and so my demand for Niagara water is very elastic. It's very flexible. I can respond. I can switch. I have the choice to find a substitute product for Niagara. So, are there substitutes for that product? Now, if I had a heart condition and had a medicine, one kind of medicine, and there wasn't a generic brand for that, then am I going to be as flexible to prices? So y'all see the difference that we're talking about here. I'm not going to be able to be as elastic, as responsive to changes in price. Okay, necessities versus luxuries. All right, so cruise ships. I keep hearing in the news about these terrible things that happen to people that go on cruises. It looks really fun, and my friends sometimes go, but then I hear about getting stuck with
my life's not stressful enough. I'm going to go take a cruise.
With no plumbing and things like that. So luxury items, we don't have to go on a cruise to take a vacation, right? We could take a road trip. We could stay at home. So luxury item like a yacht, you don't have to buy that. So if those things get super expensive, you could decide to not go, right? You can be responsive to prices. Now, do you have to have gas to get to school and get to work? All right. So in that case, we can't be as responsive to prices. That's what the second one is talking about. Definition of the market. The more narrow your definition of the market, the more elastic the demand. And this kind of goes back, it's related to the first one. But if we're talking about Coke, Coca-Cola, if that gets super expensive, what could you switch to?
Pepsi.
Okay, Pepsi, Dr. Pepper, right?
Water.
You could switch to something else. Water. If we're talking about soft drinks, okay, that takes into account all of those drinks that we were talking about, and then, then maybe water or maybe a sports drink. Now, if we widen the definition of the market even more and said food and beverages, are there many substitutes for food and beverages?
Yes.
Or that whole category. If we didn't have food and we didn't have drink, what else would we have? What else could you switch to? Maybe an IV. What we're talking about here. So a particular product, if you define the market very narrowly, so we're talking about one particular product like Coca-Cola, then the demand will be more elastic. But if we're talking about food in general as a big category and define the market very broadly, then your elasticity of demands will be lower. And then also time horizon. We mentioned that we do need gas. Whatever the price is, we need gas to get to work and school. But if you give people enough time, And if gas prices are high enough for people to be upset about it and not want to pay it, what are some other things that people are going to use as transportation? Bikes. Public transportation. Okay, maybe hybrid cars, solar power or battery powered. If you give people enough time and you give car companies enough time to think about alternative modes of transportation, then we can see over time that our demand for gasoline, for example, might be more and more elastic. Okay, so all of these things play a role in our elasticity or our responsiveness to prices. Right. So demand tends to be more elastic. That means we're more flexible, more responsive, more able to say, no, I'm not willing to pay that. If we've got substitutes, if it's a luxury item, if we're talking about a narrow definition of the market, and if we have more time to respond. All right, so basically that's what elasticity is, our responsiveness to changes in price. Here is how we calculate it. The percentage change, okay, I just showed you some examples with your meal at your favorite restaurant or a suit at Dillard's on how to calculate the actual percentage change. But we're going to need to do it twice. In the numerator part, we're doing it for quantity demanded. And then in the denominator part, we're doing it for price. So basically, we're looking at how much our sales going to change in relation to how much the price changed. And that gives us a measure of the price elasticity of demand. Remember, with this first formula, you don't have to worry about a negative sign. You don't have to worry about the sign of your product that you get when you use the formula. You'll just take the absolute value. Okay, my formula for you, and I'm going to provide this sheet for you on the test, and I'll add in this percentage change formula at the top. But I always want you to think of percentage change as the new minus the old. And they did it backwards here in the book because they were just trying to avoid that negative sign. But if you're going to get the same answer, but it doesn't matter with the price elasticity of demand. These next formulas that we're going to talk about, the sign does matter a lot. But on this one, that's why they have it switched. I would have 8 minus 10 here. So they did it. They did the new and the old here. So on top, we're looking at the percentage change in quantity demanded, and on the bottom, percentage change in price. And that's one example of how you use that formula twice, up here and down here, and then you calculate it. Okay, there will be one question on the test where you're actually going to have to calculate it out using these numbers. So put a star by this slide.
On the test, do we need to retain each formula and how they're laid out?
The back page of your test will be this formula sheet. Yeah, so I'll provide that for you.
Thank you.
And your quiz next time. You'll have those formulas. Okay, so I said if I had a heart condition and I had to take this particular medicine, you're going to have to pay the price of that medicine no matter what it is, right? If it's a life and death type of thing. And so when you're not able to change as much, when the quantity of medicine that you buy doesn't change when the price of your medicine changes a lot, we call that inelastic demand. Inelastic demand. And the price elasticity of demand is going to be less than 1. Again, if you look on your formula sheet, does that make sense? When we've got a fraction that's less than 1, like a half or a third, that means the numerator is bigger than the I'm sorry, the denominator is bigger than the numerator. So if there's a big change in price, and people aren't responding that much, they still have to buy the same amount. And we just look at it mathematically. The price elasticity of demand is going to be less than 1. The price changes quite a bit. So this is going to be a big change. And this stays about the same, or there's just a little change. My brother said that he was in the middle of taking a math test one time, and his friend came up to his teacher and said, my battery on my insulin pump is running low, and I am out of extra batteries. Can I go to the store and try to find a battery? And she said, yes. Leave now. This is really important. And so my brother said, they were all worried about him because he just got up and left, and then he drove to Randall's and Kroger and it was a special battery for not one of those regular ones that we can get in the store. And nobody had it. He had to call his dad, who lived in downtown Houston, and they had to meet halfway because his dad just happened to have some spare batteries. But his friend was telling my brother later that he was lightheaded, he wasn't feeling well, and his dad was really angry at him when he met him, but because he would have been in trouble. But whatever the price is, he would have paid it, right? If we're talking about life and death. So if there's a big change in price, they could have charged him $100 for that battery, but he still needed one. And so if you just look at the formula, if there's a big change in price and not that much change in the quantity demanded, we're going to have a fraction where the denominator is bigger than the numerator. So this whole thing is going to be less than 1. And that's what we mean by inelastic demand. Elastic demand. Okay, so think of something that you can respond to changes in. So movie tickets, for example. I know if you use your ID, you can get in for $5 there. But what if they got rid of that rule? And what if they started charging $20 to go to the movies? How many people would still go? You don't see a lot of hands. What are some things that y'all could do instead?
Dollar movie.
Go to the dollar theater.
$2.
Netflix. Redbox. Right? You would respond. Your demand for movie tickets at the movie theater would be very, what we call, elastic. And so now the price elasticity of demand is going to be greater than 1. Okay, let's think about that in terms of our formula here. If there's a change in price, if tickets go up by 10%, and college students and everybody else say, that's way too expensive, I'm not going. And so all of y'all decide to change and do something else, watch movies at home on your computer, then you can see that the whole thing, the numerator is going to be bigger than the denominator, then the whole thing's going to be greater than 1. So that's what this slide is saying. Just mathematically, it'll be greater than 1. Okay, so remember that. We have these special cases where, and we'll look at some graphs next, but we have special cases where demand for a product is perfectly inelastic. That means the quantity demand doesn't change at all. And so you might think of maybe somebody's heart medicine or insulin medicine they absolutely have to have no matter what the price changed. We can have relatively inelastic, but this is one extreme. Another extreme is perfectly elastic. That means there's only one price that people are willing and able to pay for that particular product. If it goes up by 1 cent, then that seller is going to be out of luck. People are going to switch to something else.
And that's called
The second one, perfectly elastic. And then uninelastic is one other, theoretical outcome where the quantity demanded just happens, the change happens to be exactly the same as the percentage change in price. I mean, it could happen.
Can I ask a question?
Okay.
So if price changes and customers do not respond, meaning quantity does not change,
That means that's something that they have to have. That would be the first one, perfectly inelastic.
Okay,
Yep.
okay.
And
And
here,
you buy it anyway, so then it's, okay.
and this is what that looks like. So if you have to have 100 doses of your, insulin, like my brother's friend, no matter what the price, the pharmaceutical company could charge $4 for a dose, $5 for a dose, $100 for a dose. If it's something that his life depends on, he's still going to buy 100 doses per month, right? So this is, you can remember this. Usually demand is downward sloping to the right, but in this case, for a particular product that you absolutely have to have no matter what the price, inelastic demand, remember, is straight up and down. And just graphically it represents you have to have this product no matter what the pharmaceutical company charges you. So you can remember it starts with an I, inelastic, straight up and down like an I. All right. Add to your notes here, I would call this relatively inelastic. It's pretty steep. It's almost an I, but not exactly. Usually our demand curve is downward sloping to the right like this, but you can see this one's getting closer and closer to an I. So this is relatively inelastic. And we have different degrees just based on the data that we have in terms of quantity demanded and price for a product. So the steeper that it gets, the closer and closer it gets to that straight up and down vertical line, it's getting more and more inelastic. Okay, here's unit elastic, where it's just the change is going to be the same for both the numerator and denominator. I'm going to skip to this slide. Okay, you can see more elastic demand. The demand curve is flatter. That's what we're used to seeing in chapter 4 last time, where there is some change. Now, what if we had perfectly elastic? Oh, so on this slide, just put relatively elastic demand. Okay, here, another extreme. This is perfectly elastic demand. Perfectly elastic. So if you ever see that on a quiz or test, just remember that's a straight horizontal line. Okay, what does this mean? Y'all mentioned so many substitutes for Niagara water, right? There's so many different kinds of bottled water that we're used to paying about $1 for this, right? So let's pretend this is $1. Well, if bottled water company knows that the market clearing price is about $1, why would they sell it for 50 cents? They're going to sell it for $1 because that's what everybody else is selling it for. If they try to charge $2 for it, what's going to happen to their sales?
Drop.
Okay, people are going to find a different. They're going to switch over to Design, right? Or a different brand. So this is the demand for a particular, you could think of bottled water in this case. There is no demand when the price goes up. They can try to charge $5 for a bottle of water or $10 for a bottle of water, but there's no demand there because there are so many substitutes and customers can easily respond and switch to another company that there's only demand at one price. That's what this graph means.
So when we're thinking elasticity relative to economics, it refers primarily to, in reference to how the price responds to quantity.
No, how the quantity demanded responds to price.
Yes. Sorry, yeah, that's how quantity responds to price.
Okay. Everybody's in good shape so far. These graphs. Okay, we can also look at it. We can calculate it, elasticity, we can graph it, and we can also use something called the total revenue test to describe elasticity. Okay, this is the first printed formula on your formula sheet, which will be provided to you. Total revenue is the price of the product times quantity. And we're not talking about profit yet. We'll get to that when we're subtracting out costs. But this is revenue, how much money you made. Just price times quantity. This is going to be different when the demand for a product is either elastic or inelastic. It's going to change. All right, well, let's take a look at inelastic demand. All right, it says with inelastic demands, that means it's something, so think of my brother's friend, insulin. With inelastic demand, an increase in price leads to a decrease in quantity that is proportionately smaller. Although with medicine, it would be perfectly inelastic demand. It's not going to change at all. So total revenue increases. If it's something that people have to buy, no matter what the price, the pharmaceutical company increases the price, what's going to happen to total revenue? They'll be able to make more money because people still have to buy that product. And so, just looking at your formula, if this increases, price increases, and quantity staying the same, of course, total revenue is going to increase. So if total revenue increases when you raise the price for a product, you know that the demand is pretty inelastic. And that's what this slide is saying here. Actually, let's go back here. What if the price decreases? What's going to happen to total revenue if the product is inelastic? People have to have it. What's going to happen to total revenue?
Decrease as well.
It will decrease. Yeah, so be able to think about it both ways. If the demand for a product is inelastic, like medicine, you have to have it. If it gets more expensive and quantity stays about the same, total revenue will increase, and then the opposite will happen. Quantity stays about the same, and then price decreases, total revenue will decrease. Okay. So with elastic demand, an increase in price that leads to a decrease in quantity demanded will cause total revenue to decrease. So we're talking about, let's think about movie tickets again. So if they raise the price of movie tickets, and it might not be that much, but it's enough for us to say, we're going to stay at home, we're going to watch Netflix tonight, we're not going to pay for movie tickets. And a lot of people do that. If the quantity and their sales start to go down because a lot of people decide to use Redbox or Netflix instead, just a little drop in price can lead to, or a little rise in price. Use my sheet here. So, higher ticket sales, it may just increase it a little bit, but if a lot of us say we're not willing to pay, what's going to happen to total revenue overall? Decrease. This whole thing is going to decrease. If a lot of us respond, and that's what elasticity means, right? Okay, what if the price drops? What if movie tickets with your student ID are $2? And if a lot of us respond and say, hey, well, let's go to see the movies more often, and we've got a big arrow here representing a lot of us being responsive, then what's going to happen to total revenue?
Should go.
Increase.
Another.
So it just depends on, if the demand is inelastic or elastic. A couple of years ago, I was on a committee here at NCC, and they were looking at increasing tuition. Y'all know this. It's because MCC usually gets a certain amount of money from the state. And we've heard about deficits in the news, but that's happening nationwide at the state level too. And so MCC is getting less and less funding from the state than we did in prior years. And so to make up for that shortfall, they're thinking, well, we could increase tuition. And my committee, our job was to examine different sources of revenue besides tuition. And I presented to the administration, the president and vice presidents, the concept of inelasticity. I said, you all are assuming that demand for MCC tuition is inelastic. You're assuming that total revenue is going to increase, that the quantity of students who are going to be taking hours here is going to stay the same, so that when we increase tuition, we'll be able to make up for the shortfall of the lack of state funding. And I said, we've got to be looking at Tarleton, we've got to be looking at other, nearby colleges and their tuition too, because, MCC is a great place, but, if the price is high enough, you can't just assume that students are going to be, coming no matter what the price here. And so had a discussion about this very thing in front of that group.
Thank you
Oh.
for fighting for us.
Well, you're welcome. It's just, it's very, it seems really technical here, but it's very applicable to a lot of different situations. Okay. Okay, figure 4. Let's talk about this one. Even with one demand curve, there are certain parts of it. We've been talking about different products and our, demand for it being inelastic or elasticity, or elastic or inelastic. But even along one demand curve, there are parts of it that can be more elastic or inelastic than others. How many of y'all have to have coffee in the morning? Like you're just a devoted Starbucks drinker? Okay. Austin and Dan. All right, so if your Starbucks coffee, let's pretend that it was, $3 for your coffee. Okay. Would y'all still buy it if they changed the price to $3.50? No. Austin? No. Okay, what about $3.03? So 3 cents is enough for you to change. So if you're used to paying $3.
I'm used to paying $3.
Okay.
Yeah, I'd pay.
Okay, you'd still pay? It'd still be okay with you? Austin, how much would it change for you to say, no more, I'm not willing to pay? Past $3.25. So about you're able to pay up to 25 cents more than that. Okay, this looks like a really complicated figure, but that's what this is saying, that Starbucks or any other company can charge a little bit more for their product, maybe 1 or 2, 3, in this case it's dollars, but we could be talking about cents here, and people would still pay for it. Demand is inelastic on this part of the graph. So if the price is just changing maybe $1 or $2, people will still want their Starbucks, will still want this product. They don't mind to pay a little bit more for that item, that their favorite item. So demand is inelastic here on this part of the graph, but then once you start charging, like Austin said, 25 more cents, or $5 more for a t-shirt, or $7 more for a t-shirt, people start noticing and say to themselves, I'm not willing to pay that. And so that's what this figure is saying, that there are portions of a demand curve that are inelastic, and then there are portions that are elastic in that top portion. All right. So everybody's okay on the price elasticity of demand. Okay, let's look at income elasticity of demand. Okay, we're not talking about price anymore. We're talking about income. You'll remember from the quiz and from last time, the two goods that deal with income are inferior and normal goods. Okay, that's what we're talking about here, inferior and normal goods. Okay, so the elasticity of demand, we learned what those are, the definition of those before. We're just going to apply it to elasticity here. Okay, so we're going to look at the percentage change of quantity demanded and the percentage change in income. So here's the formula for it. Let's go back to normal goods. Even if I didn't give you numbers, let's just think about what would happen to this formula. For a flat screen TV, brand name clothing, things that people usually buy more of when they have more money. Okay. What's going to happen to this formula? People have more money, the percentage change is going to be positive or negative. Remember, it's new minus old. So if there's an increase in your income from $40,000 to $50,000, would you get a positive or negative number there for the percentage change? We don't have to work it out. A positive number. So this is your denominator is going to be positive if you have more money. If you buy more sports cars, I don't know, $50,000. If you buy more brand name clothing, remember the formula for percentage change is new minus old divided by old. So if there's an increase in the number of brand name clothing items that you're buying, this is going to be positive or negative up here? Positive. So the whole thing, even if I didn't give you numbers for it, and add this into your notes, the whole thing, when you calculate income elasticity for normal goods, is going to be positive.
One more time with that. Whole thing.
The income elasticity of demand will be positive. You can just reason through even without numbers. Let me switch back over here to the formula formula sheet so I can write. All right, with an inferior good, we said these are like ramen noodles. So if you've got an increase in your income, remember the formula for percentage change is new minus old. So this whole thing is going to be positive on the bottom. But if your consumption of ramen noodles goes from 5 packets a month down to 1 packet a month, so this is your old number, this is your new number. For our formula, we're going to do 1 minus 5 over 5, right? And then get a negative number on top. So this is going to make our whole thing negative. Now, see what I'm saying? You don't even have to put numbers in here. You can just reason through in terms of the sign here. If the percentage change is going down because you're buying less of it, like we've defined with inferior goods, you know that the income elasticity of demand is going to be negative for inferior goods. It's going to be positive. And we're talking about the sign. And then here are some other examples for things that people regard as necessities and luxuries. I mentioned to you, there's just going to be one problem on the test where you're going to actually have to calculate the price elasticity of demand. I told you to star that one slide about the ice cream. These other questions about income elasticity, if I had a true-false question, the income elasticity for normal goods is usually negative. What would you say? False. And you could just reason through that with the definition and looking at the formula here. Okay, another formula is the cross-price elasticity of demand. All right, so let's look at this formula. We're looking at the quantity demanded, the percentage change in quantity demanded for one product, and the percentage change in the price of another one. Okay, with substitutes, like Coke and Pepsi, for example. If the price of Coke increases, This is going to be a positive number down here. What's going to happen to the demand for Pepsi?
It'll increase.
Increase. So this whole thing is going to be a positive number. This whole thing will be positive. For complements like peanut butter and jelly. So if peanut butter got more expensive, this is going to be, that'll lead to a positive number down here in the bottom. What's going to happen to the demand for jelly?
Decrease.
Decrease. So the percentage change for jelly is going to be a positive number or negative number if people are eating less?
Negative.
Negative. And that'll make the whole thing negative. So, oops. I don't have this in the notes, but you might just add in for substitutes, the cross price elasticity of demand is positive. Let me add this in for you. And for complements, the cross price elasticity of demand will be negative. Okay, we can also talk about the elasticity of supply. The price elasticity of supply. We've been talking about demand up to this point, consumers, but we can also talk about the elasticity of supply in terms of how responsive businesses and firms are to changes in price of the product. Okay, do y'all remember what perfectly inelastic demand looked like? If you could draw it in the air with your finger, what would it look like? Perfectly inelastic. Straight up and down, right? Like an eye. The same for perfectly inelastic supply. Okay, you already know inelastic means really inflexible or non-responsive. What does this mean in terms of a business? Before, with consumers, it was something that we had to have. Now, with a business, what would make a business really inflexible with the amount of product they're able to offer? Think of a stadium.
How many seats?
How many seats they have, how many tickets they can sell. That's it. That's all the space they have in that theater. Or you think of, in the short run, with your apartment complex. Yeah, they can add on later, but as of today, this is how many units we have. And we're inelastic in that way, no matter what people are willing to pay for the price. Okay? So just remember, straight up and down for either inelastic supply or inelastic demand, if you see that on a test or quiz. Then we have, just like demand, we've got relatively inelastic. That's pretty steep. I'm going to go pretty quickly through these next ones. On D, you can see that it's getting flatter and flatter, and perfectly elastic supply looks just like perfectly elastic demand. Okay, what does this mean? That we can supply as much as we want at this price. Can y'all think of a business? What type of business is able to produce a whole bunch of stuff? They're not limited. Don't think of an item that's really easily. You can make several copies of it easily. Software. Music CDs. Books, printing, toys. So think of a manufacturing business here. They're able to make a bunch of copies or a bunch of items at this price. So that's what an example of perfectly elastic would be. So suppliers can either be elastic or inelastic, and there are the extremes of perfectly inelastic and perfectly elastic, but they can be relatively either one as well. But those are some examples. One last thing I want to talk about, and then I'll give you your bonus question. All right, the price elasticity of supply, here's the formula for it. It's just like the price elasticity of demand formula, except that we're talking about quantity supplied now. But we were talking about the total revenue test. All right, how would you describe this demand curve? Relatively elastic or relatively inelastic? Just looking at the shape of it.
Relatively inelastic.
Relatively inelastic. It's pretty steep. We're talking about food here. The demand for food, your author argues, is relatively inelastic. We only eat 3 meals a day. You could buy a whole bunch of food if you wanted to, but it only keeps in your refrigerator for a few days. And so even if food was really super cheap, or we're talking about fresh, wheat here, or some produce, that our demand for that is relatively inelastic. I mean, there's only so much that we can eat and consume and that we're going to want, even if the price is cheap. So that's what that means. Okay, how would you describe this supply curve? Relatively elastic or relatively inelastic?
Relatively inelastic.
Relatively inelastic as well. Okay, why is supply for wheat relatively inelastic? Your author says that farmers, they plant a whole bunch, and then when it's time to reap the crop, it's just going to depend on what they did a long time ago. And it's not like they can keep printing out new books or burning new CDs. They're pretty limited in terms of the response to price. It's just the crop that they yielded. Okay, so there's equilibrium, like we're used to looking at. Okay, so we're saying that 100 items of wheat, bushels of wheat, are being sold at $3 each. When the demand and supply for a product like wheat are relatively inelastic, let's see what happens when there's a bumper crop. And this year there was a lot of rain, and it was really plentiful in terms of the crop yield. So what's that going to do to supply if we have wonderful crop yield? Shift it to the right. Okay, and there's our new equilibrium. Okay, now hold on. 1 second. Total revenue before the shift. When we had just regular yields of 100, we could bring 100 bushels of wheat to the marketplace. What's our total revenue? Remember, it's price times quantity. 300, so 3 times 100. Now, this year we had a great bumper crop. Y'all already know from your homework that when supply shifts to the right, our equilibrium price decreases and equilibrium quantity increases. But now, what's total revenue? 220. It actually hurt farmers to have a bumper crop because of the relatively inelastic supply and demand for this product. If it was something that we could keep and people could hoard and buy a bunch of it, save for later, then that would be different. But in this case, with a perishable item like wheat, we see that the relative elasticity of supply and demand can, affect, in this case, farmers, and it can affect a business's total revenue. And I think we'll go ahead and stop right there. So that's the end of chapter 5.